again. So basically, ladies and gentlemen, when we're dealing with the cube roots, the main important thing I want you guys to understand, when we're trying to simplify the cube root, we want our index to be the same as our powers. So the main important thing is if we don't have a number, Ryan, that's raised to a power, the first thing we want to do is rewrite our number as an exponent that we can see. So I automatically see that I can rewrite this as the cube root of 9 squared times x. However, what we're trying to do, again, when you're dividing, I always said always divide first. But in this case, I'm sorry, it's 3, right? I know, I'm sorry. Sorry, I'm thinking ahead. Or I don't know, I wasn't thinking ahead. Just wasn't even thinking. So does everybody agree that these are exactly the same? Yes. But what we're trying to do in this case is, since we can't divide the numerator and the denominator, we're going to eliminate the denominator. We're going to eliminate the cube root. The only way to take the cube root of something is when you either circle 3 of them, right, like we did with prime factorization, or when the power and the index are the same. So here I have 3 squared. I don't need it to be 3 squared. I need it to be 3 cubed. So therefore, I need to multiply by 3. But remember, we can't multiply a number inside of a radical. We have to multiply it by the cube root of 3. Then I have an x, but to take the cube root of that x, I need it to be x to the third. Well, I need it to be x to the 3rd power, so therefore I need to multiply by x squared. Now, when you multiply by the cube root of 3x squared on the top and the bottom, what you've now obtained is the cube root of 3x squared over the cube root of 3 cubed times x cubed. Does everybody see that? Now, can I take the cube root of 3 cubed? Yeah, can I take the cube root of x cubed? Yes. So my final answer is going to be the cube root of 3x squared divided by 3x. OK, so this is just a little extension on what we did last class period. Always